Hello, AP Chemistry students. This is Mrs. Altman. We are on video number 25, Chemical Equilibrium, Part 1. This is in Chapter 13 of your textbook. Here are our objectives for today's video. Pause here. You do not need to label the picture. You've probably heard me talk about chemical equilibrium or just equilibrium before. All equilibrium means is that there is no net change in concentration. So that might mean that a reaction is happening. Let's say a forward reaction is happening, but the backward reaction is happening at the exact same rate. So therefore, there is no net change over time. It does not mean that nothing is happening. It just means that the concentrations of reactants and products are not changing. What this picture is just showing is that in this particular instance, before equilibrium was reached, the backward reaction rate had to increase, the forward reaction rate had to decrease until they were equal to one another. That is what equilibrium is. Pause here. So the equilibrium constant is going to be the backbone of really the next 2 months of what we're going to be learning about. All it is products over reactants raised to coefficients. So everything in the first equation, that is all aqueous. That's why we're using concentration here. Sometimes we're going to use partial pressure, hence the equation at the bottom. More often than not, we're going to be using Kc. And more often than not, it's actually not even going to be labeled Kc. It's just going to be labeled K. And the reason for that is if you take a look at that lower equation, where it is Kp is equal to K times RT raised to the delta N of gas. If delta N of gas is 0, meaning I've got just as many moles of gas in the products as I have in the reactants, then Kp is equal to Kc. So that's why you're so often going to see them used interchangeably. If it's not labeled and it's just uppercase K, you could assume that it is in terms of concentration. Pause here. I'm just going to show you why this is all true, just using these equations here. So I have a chemical equation here. And it has just products over reactants as its Kc. So if I take this reaction and reverse it, I'm going to call this C prime, I guess. Doesn't really matter. It's just a different reaction. It just so happens that if you flip the reaction, then the new equilibrium constant is going to be the reciprocal, meaning just K raised to the -1 power. And then I have another reaction really similar to the first one, except everything is multiplied by 2, all of the coefficients. So rather than writing that out, I could have just taken my original Kc and squared it, just to save myself that work. In retrospect, that should be double prime as well. Pause here. Okay, so when we know something is at equilibrium, and we know its equilibrium expression, we can just plug all the values in and get a number for K. There is not only one solution to K, there's an infinite number of ways to get there. There's typically 2 to 4 variables going on there, so you're going to have multiple correct answers. But if you don't know that something is at equilibrium, you can just, instead of calling it K, call it Q, and it will just tell you how far away you are from equilibrium. So if Q is equal to K, then you're at equilibrium. If Q is greater than K, then you've got too many products and it needs to shift to the left. If Q is less than K, you've got too many reactants and it needs to shift to the right. Let's take a look at this in application. Pause here. Okay, let's work through this. So if it doesn't specify, you could assume it's in terms of concentration, even if you have gases going on. Okay, so the first one's pretty straightforward. And now in part B, they are giving us concentrations, so we're just going to plug in. These typically aren't sig fig questions, but just for the sake of doing this like how we normally do it, I'm going to round to 3 sig figs because that's the lower amount. So K is equal to 115. Right, and then for part C, it says it gives different concentrations. So I'm going to just plug those in. Right, so Q is a lot less than K. So what this tells me is that I need to produce more products. So what's going to end up happening is that a lot more HF is going to be formed in order for this to reach equilibrium. Okay, and here are the practice problems for today's video. Thank you so much for watching and have a great night.